Good day, everyone, and once again we are back together. Right, and today we are looking at the IEB Mathematics Paper 1 for November 2023. Hey, some people have been telling me that it was a bit of a nightmare in some parts. So please, if you haven't subscribed, just make sure you're part of the family. And please, you can get in touch with us. Our email is info@mlungisinkosi.co.za. Okay, if in case you need any extra help on mathematics, we're available for you. All right, let's get into this question paper. Right, so the first question there, they say solve for x in each case below. Right, 2 is to 3 exponent x. So what we simply do there, the bases are not the same. So what we're going to do is we're going to introduce logs. Log 2 is equal to log 3 exponent x. You know the laws of logs, they say, well, we can jump down and have that log, that exponent come down there, right? So this is equal to log 2. So divide by log 3 on either side. Okay, so that cancels with that. And so x would be equal to log 2 over log 3, but we can also write this as log base of 3, okay, log 2 base 3, all right? Okay, so going to the next question. Right, now we are solving there. We've got a third, but remember we can actually square both sides. So what we're going to do is isolate the square root there. So we're going to have x plus 7 is equal to, take the 1 to the other side, and so that becomes x plus 1. And all we're going to do now is just square both sides, right? So we've got x plus 7 equal to x squared plus 2x plus 1. And now we're going to have x squared. Now if I bring the x to the other side, it will become 2x minus x, which will give me plus x. And if I bring the 7 to the other side, it becomes 1 minus 7. That gives us minus 6. Okay, and this is equal to 0. And we can factorize. So minus 3 and 2 there. So x plus 3, x minus 2 actually equal to 0. So x is equal to negative 3 or x is equal to 2. Now it's very important for you to go and test the solution when you are squaring both sides. So let's see, if I substitute negative 3, so I've got on the, before I had the squares, I had the square root of x plus 7 equal to x plus 1. So if I substitute negative 3, I'll have negative 3 plus 7. That will give me 4, right? Square root of 4 on this side will give us 2. And here I've got negative 3 plus 1. And that gives me negative 2. There is no way that a positive square root can give us a negative answer. So this is not a solution. But if we substitute 2 there, we've got 2 plus 7, which gives us 9. Square root of 9 is 3, right? And if I substitute 2 on the right-hand side, I've got 2 plus 1, which gives us 3. So positive and positive, so definitely this must be a solution. Okay, let's go to the next question. They say solve for x and y simultaneously. All right, so what I'm going to do is I'm going to start with y is equal to 2x. All right, I'm going to bring the 2x to this side. All right, so it's going to be 2x plus 7. And I'll call this equation 1. Right, and I'll call the other equation 2. Okay, so in this case, substitute equation 1 into equation 2. Everywhere I see y, I am going to substitute 2x plus 7. So this is minus, please put it in brackets, 2x plus 7 minus 3, this is equal to 0. So we've got x squared minus x minus 2x minus 7 minus 3 equal to 0. So this will be x squared minus 3x minus 10 is equal to 0. So if we factorize, we've got x and 5, we've got x and 2. And in this case, our 5 becomes negative, our 2 becomes positive. So we've got x is equal to 5 or x is negative 2. Now to find the corresponding y values, we are going to just simply substitute back into equation 1. So y will be 2 times 5 plus 7, or y is 2 times negative 2 plus 7. Okay, so 2 times 5, that's 10 plus 7 gives us 17. Okay, or in this case, y will be equal to negative 4 plus 7. That will give us positive 3. All right, and that is our solution. Now they're asking us on the next one, for what values of x is 3x squared less than x? So what we're going to do is we're going to find our critical values first. So I'm going to bring the x to the other side, 3x squared minus x less than or equal to 0. So if we take out x as a common factor, we've got 3x minus 1 less than or equal to 0. Now you'll note there are critical values. In this case would be x is equal to 0 if we were solving. And another one, it would be x is equal to 1 over 3. So we've got two critical values, x0 or x equal to 1 over 3. So if we draw a number line there, so that means the first, remember you write it in ascending order, right? So that would be 1 over 3 over there, right? Now note, where is this less than 0? Okay, so note in this case, the critical values, so we know we'd have plus, negative, and plus there. Remember, this represents a parabola, right? And in this case, it means this would be our x-intercept at the critical values. So where is our parabola less than 0? It's definitely between 0 and 1 over 3. And in that case, remember, we will include that because they said less than or equal to 0. So our answer there should be x is an element of 0, which is included. So we put a square bracket to 1 over 3, which is also included, okay, in this case. Or you can write this as x is less than or equal to 1 over 3, but it is definitely greater or equal to 0. Okay, right, so that is how question 1 goes, right? We're going to go into question 2. So they say if f of x is equal to x plus 2, x minus 4, and x minus 4, then determine the equations for the y-intercepts of the graph. Now note, what happens at the y-intercept? We know this is where x is equal to 0. All right, so which means that we're going to say f of 0, that's 0 plus 2, that's 0 minus 4, and that's another 0 minus 4, right? So if we multiply those out, this would be negative 2 times negative 4 times negative 4. In that case, that gives us, so 4 times 4 is 16 times 2. That gives us 32, right? So our y-intercept is 32. So we know in this case, the coordinates of the y-intercept would be where x is 0 and y is 32. So they say determine f prime x. To do that, we'd need to multiply out first and get f of x. So that would be x plus 2 into, now if I multiply those two brackets together, I get x squared minus 8x plus 16, right? And so if we multiply that out, so we'll have x cubed minus 8x squared. Okay, so that's x cubed minus 8x squared plus 16x. Okay, and that's plus 2x squared minus 8 times 2 is 16x, and 2 times 16, that's plus 32. Okay, so our final equation is x cubed. So our x squared terms, that's going to be minus 8 plus 2. That gives us minus 6x squared. 16x and minus 16x, those cancel out. And so this would be plus 32. All right, so that's our f of x. And so to get f prime x, we're going to now say this is going to be 3x squared minus 12x, actually minus 12x. That's it. Because remember, that's a constant and it falls away. Now they say for which values of x will f prime x be equal to 0? So it means in this case, we're going to take 3x squared minus 12x equal to 0. That's our f prime, okay, equal to 0. So this is going to be, if I factorize that and take 3x out, I can take 3x out. That gives me x minus 4. This would be equal to 0. So this will be at x is equal to 0 or x is equal to 4. Right, so I could already tell that one of my my x-intercepts would actually be the turning point, right? Because it was repeated there. That bracket was repeated, right? Okay, so we know it will be equal to 0 there. Right, now they say to us on the same set of x's provided, right, sketch the graph of f. Okay, so now we know we're going to have our x-intercepts at 4, right, as well as at minus 2, I think it was, right? So it was going to be at minus 2, yes, and 4. And we're going to have our y-intercept at 32. So let's say 32 somewhere there. Okay, so 0 and 32. Okay, now another thing is that we know that our a value is positive. So our graph should look like that. This is for a greater than 0. Okay, so it crosses through 2 and we've got a turning point there. Now we can find the other y value of the turning point, right? So we know that in this case, our turning point is also going to be at x is equal to 0. Oh, I can already see what's happening here, that the y-intercept is also the turning point. So that means that our y-intercept, okay, we said this is 0 and 32. Okay, so this is what it looks like. They said we should also show the point of inflection. And please remember, ladies and gents, the point of inflection will be halfway between our turning point values, right? So in this case, I've got 0 and 4. So our point of inflection will be actually at x is equal to 2, right? So now they said we need to show the point of inflection. So when x is equal to 2, in this case, so we can actually go back to our diagram there, right, and say f of x is equal to 2. So if we substitute 2 there, right, so if we substitute x is equal to 2, 2 and 2, so this will be 2 plus 2 will give us 4, and 2 minus 4 will give us negative 2 and negative 2. So that means that we'll have 4 times 2 times 2, and that will give us 16. So our point of inflection will be at x is 2 and y is 16, right? So that's 2 and 16. Let's just say somewhere over there. Okay, let's point 16 at that point. Now I'm going to try and complete my graph. Okay, I know it's not going to be necessarily the most accurate, and this is what our graph is going to look like. Okay, right, you can actually find the other points if you want to. All right, but this is in the long and short how our graph is going to look like. All right. So ladies and gents, let's continue. They said label both the x and the y intercept. So we need to label that. This is going to be 0 and 32. Okay. They said we need to label that. That's 2 and 16. Right. And our turning points as well. This is going to be at at 4 and 0. Okay, as well as that point over there, which is -2 and 0. Okay, I'm just going to write it over there. That's -2 and 0. Right, now let's continue. Now they say for what values of x is f of x greater than 0? Now, ladies and gents, where is our graph positive? You can see it becomes positive after we cross x is equal to 2, and it becomes positive all the way up until infinity, right? Right, so in this case, it means that our solution will be x is greater than or equal to 2, okay? Right, so that's where the graph is positive, or you can say x is an element of -2, I should say, greater than -2. Or you can say x is an element of -2, which is included because they said greater or equal to, right? All the way up until infinity, right? Okay, right, and infinity would be excluded. Remember, at 4, it is equal to 0. Okay, so in that case, that would be included as well. All right, so on the next one, question number 3. The graph of f and g have been sketched on the set of x's below, right? So they've got f of x is equal to the log of x plus 2 base m, and g of x is minus x plus 4. Now they say to us b and c are the x and y intercept of the graph of f respectively. They say a, which is 3 and 1, lies on both f and g. The dotted line through d with equation x is equal to -2 is the asymptote of f. Right, so in this case, they want us to answer the following questions. They say f of x is equal to log m of x plus 2. Determine the values, or rather the value of m. Now note in this case that we've got a point that we know, which is point A, which is 3 and 1. So I'm going to substitute that when x is 3, right? So log m of 3 plus 2, well, y is equal to 1. So let's try and solve for that. Now, if you know anything about logs, that would be log 5 base m is equal to 1. Now remember, this guy becomes the index, right, or the solution. So that's 5, and the base becomes the base of our exponent, and in this case our answer becomes the index. The index, which is the exponent. So m would be equal to 5. Okay, right, please familiarize yourself with the laws of exponents there. Right, so m is equal to 5. Now they say to us, determine the coordinates of b and c, right, if m is equal to 5. Now let's do that. What's happening at b and c? Remember, they said to us that's the x and the y intercepts, right? So that means, right, let's start with the x-intercept. Okay, so which are the coordinates of b in that case? So we know that the log, remember that at the x-intercept, y is equal to 0, right? So that would mean that log of x plus 2 base 5 is equal to 0. Now let's try and solve for that. That would mean that x plus 2, okay, is equal to, that's the base and that's the exponent. So x plus 2 is equals to 5 exponent 0. Remember, anything to the exponent of 0 to the power 0, in this case, will be equal to 1. So this is x is equal to 1 minus 2, and that would be negative 1, right? So that means that the coordinate of b, the coordinates of b are going to be negative 1 and 0. Now let's go to the coordinates of c, right? That's negative 1 and 0. Now for c, we know that in this case, this is where x is equal to 0. So we're going to say, well, this is f of 0 is equal to log of 0 plus 2 base 5. Okay, so in this case, this is log 5 and log 2 base 5. Okay, so we can find that, we can use our calculator there. Okay, so we can say log, in fact, let's use our log 5. Remember, this is log base 5, all right, of 2. I'm trying to actually find the ones where I can manipulate on my calculator. Okay, oh, there we go. Log base 5 of 2, right? So this will give me 0.43, right? So which means that the coordinates of c are 0, where x is 0, y is 0.43. Right, and there are my coordinates over there. Now they say, for what values of x is f of x less than g of x? Now firstly, let's look at it. F of x less than g of x. So if you note there, where is f below g, right? That's definitely in this area here, right? But of course, we're going to exclude that asymptote there, because the graph of g does not, the graph of f rather, does not exist at that point, right? So it will be from x is negative 2, our asymptote, right? And up until this point here where they actually intersect, which is point A, until x is equal to 3. Right, so from negative 2 up until 3. So in this case, I'm simply going to say, well, x is an element of, now note that it said less than or equal to, so that's negative 2, but we're going to exclude negative 2 because the graph of f doesn't exist there, right? And in this case, all the way up until x is equal to 3, but we're going to include that because they are equal at that point. Of course, another way we could have written this is x less than 3 and greater than negative 2. Okay, I hope that makes sense, ladies and gents. Right, now they say on the same set of axes, sketch the graph of the inverse of f, right? And label the intercepts, the asymptotes, and the point where f, the inverse is equal to the graph of g, right? So what would the inverse of f look like? Okay, now note that we've got an asymptote, a vertical asymptote, so which means that the graph, the inverse graph, would have in this case a horizontal asymptote. So let me just take my ruler there so that it looks a little bit neater. Okay, so there's my ruler disappearing. Okay, so I'll try. Okay, this ruler definitely doesn't want to cooperate. So yeah, it just keeps disappearing, doesn't it? Okay, so I'd have, there's my asymptote over there, right? So what happens in that case? That would be an asymptote at x is, y rather, is negative 2, right? And everything, remember that the graph of the inverse, right, changes everything around. So remember, we had an x-intercept at negative 1 and 0, now we are going to have a y-intercept at -1 and 0, okay? And we had a y-intercept, okay, at 0.43, if I remember. Yes, it was 0.43, right? So now we are going to have an x-intercept, right, at x is equal to 0.43. So we know we're going to have 0.43 somewhere there. Okay, so let's say 0.43 somewhere there. Right, now note, guys, in this case I'm going to try and draw my graph. Okay, so the graph of f is going to look, now remember this is going to be our asymptote. Okay, right, I'm just trying to put the graph together. And by the way, we had 1 and 3, right? So the graph of f minus 1 would have, we had 3 and 1, we're going to have 1 and 3 for this graph. So when x is 1, okay, let's put 1 somewhere there. All right, the graph is equal to 3. So let's just put the graph somewhere over there. Right, I'm sure that this would be, right, this would be plausible over there. Right, so let's try and draw the graph. So I would have a graph that does this. Okay, all right, let's undo that. Okay, right, you'll have to just do with the with my graph that is somewhat squiggly. All right, so this is what the graph of f minus 1 would look like. Okay, right, so that's f minus 1 of x, the inverse of f. Right, and they asked where do these graphs meet? So where does the graph of f of x meet the graph of g of x, right? So firstly, let's do this. We'd have to find out what our inverse graph is, right? So that means that everywhere I see x, remember that f of x, by the way, we know that the graph of f met the graph of g. In fact, that was supposed to be the point 1 and 3 over there. Right, so that means that it would meet the graph at 1 and 3. We don't even need to calculate that. So it would be at the inverse of that. Okay, right, so did we do everything on the same set of axes? Yeah, they label the intercepts, the asymptote. Okay, so let's label all our points. So we know that this point here would be 0 and -1. Okay, this point over here would be 0.43 and 0. Okay, that's the point over there, right? And we showed there we've got 1 and 3. Right, ladies and gents, that's where we are going to leave this. Okay, so let's go to the next portion. Question 4. Find f prime x and g prime x respectively for each of the following. Now please remember, before you take the derivative, the first thing that we ought to always do is to make sure that you remove all the surds, you remove all the brackets. Okay, so we're going to have in the first term x is 2/5, okay, minus 3x minus 3, right? Okay, so if we find f prime x, this is going to be 2/5, x of 2/5 minus 1, okay, will become minus 3/5. And this is minus, okay, so negative times a negative will be a positive, So this is 9x minus 3 minus 1 will give us minus 4. Okay, and if you wanted to write them as positive exponents, this would be 2 over 5x to the 3 over 5 plus 9 over x to the exponent 4, right? Right, so the next question, they said to us g of x, so we need g prime x. So first of all, let's try and get this in the most simplified form possible. So if you look at the top, we can actually factorize that. That would be x minus 1 squared. This is divided by 4 times x minus 1, right? So this guy and that guy cancel, right? So what are we left with? We've got 1 over 4 into x minus 1, which is 1 over 4x minus 1 over 4. Right, so to get g prime, this would simply be 1 over 4. That's it. Okay, so that's going to be 1 over 4. Right, so the next question, they say to us, the following information is given for a function of f, right? So f of 4 is 5 and f prime 4 is equal to 7. They say to us, determine the equation of the tangent to f at x is equal to 4 in the form y is equals to mx plus c. Now note in this case, by giving us f prime at 4, this is the gradient of that tangent, right? So we already know that the equation is going to be y is equal to 7x plus c. So, but we know that when x is 4, y is 5. So I'm going to substitute that point 4 and 5 there, right? Y is 5 when x is 4, right? So to get the c value, 7 times 4 gives us 28, all right? And if we take that to the other side, negative 28 plus 5 gives us negative 23. That's our c value. So the equation will be y is equal to 7x minus 23. And now question 4 says find f prime x and g prime x respectively for each of the following. Now please remember, before you take the derivative, the first thing that we ought to always do is to make sure that you remove all the surds, you remove all the brackets. Okay, so we're going to have in the first term x is 2 over 5, okay, minus 3x minus 3, right? Okay, so if we find f prime x, this is going to be 2 over 5, x of 2 over 5 minus 1, okay, will become minus 3 over 5. And this is minus, okay, so negative times a negative will be a positive. So this is 9x. Minus 3 minus 1 will give us minus 4, okay? And if you wanted to write them as positive exponents, this would be 2 over 5x to the 3 over 5 plus 9 over x to the exponent 4, right? Right, so the next question, they said to us g of x, so we need g prime x. So first of all, let's try and get this in the most simplified form possible. So if you look at the top, we can actually factorize that. That would be x minus 1 squared. This is divided by 4 times x minus 1. Right, so this guy and that guy cancel, right? So what are we left with? We've got 1 over 4 into x minus 1, which is 1 over 4x minus 1 over 4. Right, so to get g prime, this would simply be 1 over 4. That's it. Okay, so that's going to be 1 over 4. Right, so the next question, they say to us, the following information is given for a function of f, right? So f of 4 is 5, and f prime 4 is equal to 7. They say to us, determine the equation of the tangent to f at x is equal to 4 in the form y is equals to mx plus c. Now note in this case, by giving us f prime at 4, this is the gradient of that tangent, right? So we already know that the equation is going to be y is equal to 7x plus c. So, but we know that when x is 4, y is 5. So I'm going to substitute that point 4 and 5 there, right? Y is 5 when x is 4, right? So to get the c value, 7 times 4 gives us 28, all right? And if we take that to the other side, negative 28 plus 5 gives us negative 23. That's our c value. So the equation will be y is equal to 7x minus 23. Right, and so we move to question C. Of that, they say using first principles, find h prime x if h of x is 5x minus 8. Now, so the first thing, we always say h prime x, that's limit as h tends to 0, as x, h tends to 0, where f of x plus h minus f of x over h, right? So in this case, I'm going to say, well, limit, remember you don't drop this until you substitute for h is equals to 0, right? And in this case, we're talking about the difference between the 2 points, right? So in this case, what's f of x plus h? That's 5 into x plus h minus 8 minus f of x. Now f of x is 5x minus 8. Okay, this is divided by h. And all we are going to do is just try to simplify that. So we've got 5 of 5x plus 5h minus 8 minus 5x plus 8. And of course, you see this and that will cancel. Negative 5x and 5x will cancel, right? So this will give us, this is divided by h, right? So what are we going to get there? Right, we're going to remove that h there. So the h cancels out. So remember, we're left with 5h divided by h, and those cancel out. And so in this case, that means that f prime of x would simply be equal to, in fact, let me write it there, f prime x would simply be equal to 5. We didn't even need to substitute that h is equal to 0 in there. Right, so we have a look at question 5. So they say to us, we've got, consider the arithmetic sequence 22, 25, 28, and 31. They say give the number of terms in the sequence. Well, in this case, we have the last term, and the last term is 262. We've got the first term, so we can actually use, in this case, Tn is equal to a plus n minus 1 times d. So first of all, our a value is 22, and our d value will just take t2 minus t1. 25 minus 22 gives us 3. and that should give us 262. What is the n value that will give us 262? Okay, so I'm going to say 22 plus, this is n minus 1 times 3, and this should give us 262. Right, so if I subtract the 22 that side, so we've got 3 into n minus 1, which will give us 240. Okay, and we'll divide by 3 on either side. We've got n minus 1 is equal to 240 divided by 3 gives us 80. And so n will give us 81. All right, so that means that is term 81. All right, going to the next one, they say represent the sum of all terms using sigma notation. Now, for our sigma notation, let's do this. Let's express the general term of the sequence. So in this case, let's have, this is going to be a plus n minus 1d, but we already know what a is 22 plus n minus 1 times 3, right? So this gives us, that's 22 plus 3n minus 3, and that will give us 22 minus 3 will give us 19, okay, plus 3n. Right, so this is the general term of the sequence. This is the n term of the sequence. So to express this in sigma notation, we're going to say 19 plus 3n, right? N is equals to 1 all the way till 81, right? In this case, that is the sum of n terms from the first till 81 of 19 plus 3n. All right, that's how we represent it. Now they say if the pattern continues, determine the smallest number of terms that must be added to the sequence above so that the sum of all terms will be more than 15,000. Okay, so remember we already have, till 81 terms. So we want to know how many more must we add so that the sum will give us something greater than 15,000. So we're going to look for Sn, and this time we don't have the last term, right? So this is going to be Sn is n over 2 into 2a plus n minus 1 times d. Okay, and this must be greater than 15,000. Okay, right, so n over 2, we don't know what that is. Okay, that's going to be 2 multiplied by 22. Okay, plus, so that's n minus 1 times 3. So I'm just going to say 3 into n minus 1, right? So that should be greater than 15,000. Okay, so I'm just going to try and solve this as much as I possibly can, right? So multiply by 2 on either side. We've got n into 2 times 22 will give us 44 plus 3n minus 3, okay, which is greater than, remember I multiplied by 2 on the left hand side. Whatever I do on the left, I do on the right. So that should be greater than 30,000 if I multiply that by 2. Right, so let's try and multiply out by n. But first, 44 minus 3 will give us 41. Okay, so that will be 41 plus 3n. So we've got 41n plus 3n squared, right? And that should be greater than 30,000. Okay, so I don't know if we can factorize this. So let's let's put it in standard quadratic form. 3n squared plus 41 minus 41n rather. Okay, minus 30,000. is greater than 0. All right. Let's see. Are we able to... Okay. Let's see. If we do this, if we say 41 divided by 3, okay, that gives us a fraction. So, all right, we can't find the factors of 3 in this case. So we're going to say this is n is equals to minus b plus minus the square root of b squared minus 4ac. Okay, I'm going to use the quadratic formula divided by 2a. Okay, if we substitute there, so that's minus 41 plus minus the square root of, let's see, we've got 41 squared minus 4 times our a is 3, and our c value is negative 30,000. Okay, and divided, we're going to divide all of this by 2 times 3. All right, so I'm just going to whip out my calculator. And if you don't mind, ladies and gents, I'm not going to take the negative form in this case. If I say minus minus, that will give me a negative number of terms. So I'm just going to take a negative 41. So let's do this. Let's say negative 41, okay, plus the square root of, we've got 41 squared. Okay, negative times a negative will be a positive, so I'm just going to say 4 times 3 times 30,000. Okay, and this is divided by 6. Okay, so I get 97.89, right? So those are my critical values, right? So n would be equal to 80,000 in this case. N would be equal to 97,000. Okay, well, let's say they said round the sum of all terms must be more than 50,000, 15,000. So which means the smallest that n can be. Now remember, in this case, I got n to be around 98. Okay, so let's say 98, right? Let's round it off to the nearest. Remember, we wanted greater than, so that would be 98. Okay, so if we take 98 terms, definitely we'll get a sum less than 15,000, right? But remember, we must still subtract the number of terms that we had initially, which were 81, right? So that's minus 81. So in this case, I'm going to say 98 minus 81, and that will give me 17 terms. So we must add 17 more terms, okay? Anything greater than 17 terms added will be greater than 15,000, okay? Right, so I don't know if I'm expressing that correctly, but yeah, n must be any value from 17, or actually I should perhaps say n should be greater than 17, okay? Right, so that we have more than 15,000. Right, guys, that is really how we are going to answer that. Let's go right into the next question. All right, question 6 says you invest into 2 different investment schemes, that's on financial maths, for a period of 5 years. I say investment 1, you place 3,500 into an investment. At the end of each month, interest on this investment is 15% per annum, and it's compounded monthly. Right, investment 2, you make a deposit of 24,000 immediately, and then make a second deposit of 7,000 in the same account at the end of the 3rd year. Interest of this investment is 20% per annum, compounded quarterly. If you combine the value of the 2 investments at the end of a 5-year period, then what is the value of this lump sum? Give your answer correct to 2 decimal places. Right. Let's start with investment 1. Okay. So in investment 1, right, so we know that we are contributing an annuity in that case. So we are looking for a future value. So I'm going to use my future value formula. So I'm going to say, right, because I'm looking for a future value, that's going to be, that's 1 plus I exponent n minus 1 divided by I. But remember, in this case, we're still going to work out. Now, in this case, we're depositing 3,500. Okay, our interest per annum is 15%. So I'm going to say this is 1 plus, now 15% is 0.15, but this is compounded monthly. So this is going to be over 12, right? And this is going to be 12 multiplied by 5. Okay, that's minus 1. And that will be divided by 0.15 over 12. Okay, so let's calculate the value, the future value of our first investment. So this will give us 3,500. Okay, I'm gonna open brackets there. Okay, so that's 3,500. All right, so I'm just struggling to, so we open brackets there. So this is going to be 1 plus another 0.15 divided by 12. Okay, and we raise this to the, okay, so we raise this to the exponent. 12 times 5 is 60. So I'm going to say yx 60. And this is, we're going to subtract 1 from there. Right, so subtract 1. I'm going to close that bracket, and this is divided by 0.15 divided by 12. All right, so I get an amount of 310,010 rands and 78 cents, right? So that's what I would get for the future value of my first investment, right? Now let's go to the second investment. They said you make a deposit of 24,000 immediately, and then only make a second deposit of 7,000, right, into the same account at the end of the third year, right? So interest is on this investment is 20% per annum. It is compounded quarterly. All right, so notice in this case, so what would I have? I'm going to put 24,000, right, initially. And then after 3 years, in this case, so that would have been 3 years. And so I'll be left with 2 years. I make another investment there. I put in an amount of 7,000, okay? So this is after the 36th month. So this is month 0, this is month 36. So we put in 7,000 over there. All right, and we want to notice how this will actually earn interest. So what I'm going to do is I'm going to deal with the 24,000 separately, and I'm going to deal with the 27,000 separately, right? So I'm going to say, right, so it means the accumulated amount will be the 24,000, right? But now remember, so this is P into 1 plus I exponent n, because we are talking about compound interest there, right? So we're going to say this is going to be 24,000. So I'm dealing with the 24,000 first. That's 1 plus. The interest is 20%, right? Just to remind ourselves there. So 0.2. Now remember, it is compounded quarterly, right? So that means that it would be divided by 4, right? How many quarters in a year? So remember, this is going to be 5 years, but 5 years has got how many quarters? Right, so that would be 5 times 4. Right, now, and then I'm going to deal with the 7,000. So that's 7,000 into, that's 1 plus, again it's 0.2 over 4, right? And again, I'm going to say, well, this stays only for 2 years, and it's going to be a quarter of the, compounded quarterly. Right, so let's try and calculate that for ourselves. So that's 24,000. Okay, and that's going to be into 1 plus 0.2 over 4. Okay, and we are going to raise that to the exponent 5 times 4. And this is going to be 5 times 4, that's 20. Okay, right, and then I'm going to add this to 7,000. Right, that's 1 plus 0.2 again over 4. Okay, and this is raised to the exponent. Right, so we're only left with 2 years in that case. So that will be 2 times, that will be raised to the exponent 2 times 4. Okay, and I get an amount of 74,000. So the total amount would be 74,021, right? And 33 cents. Right, so that's the accumulated amount. So the total that I have from this investment would be 310,000. Okay, so that would be 310,010.78 plus, I'm going to say plus 74,021, okay, and 33 cents. Right, and I get an amount of 384,032, right, and 11 cents. Right, so that is how I was going to do that question. Right, let's go on to the next one. They say to us, to start your ice cream business, you take out a loan of 250,000. The bank offers an interest of 10% per annum compounded monthly. How much should you pay each month if you would like to pay off the loan at the end of 10 years? If the first payment is made at the end of the first month, give your answer correct to 2 decimal places. Now we're looking at, in this case, the present value, right? So we're going to use our present value formula. That's going to be x into, that's 1 plus, that's going to be 1 plus I minus n, right? This is divided by I, right? So in this case, in our present value formula, we are trying to pay off 250,000. Okay, that's our present value. And we want to know how much we want to pay. So that's our annuity. That's 1 plus. So in this case, that's 1 plus I. So our interest is 0.1. That's 10%. Right, that's compounded monthly. So that's over 12. Right, that's minus. Remember, in this case, we want to pay off the loan in 10 years, right? So that would be 10, but remember that's in months, okay? Right, so this would be over, in this case, 0.1 over 12. Okay, actually this should be 1 minus, sorry about that. So that's 1 minus, okay. Right, so let's try and calculate that quickly, right? So, see. So we're going to cross multiply there, and guys, please just remember and divide by that entire thing. So I'm going to say 250,000 multiplied by 0.1 over 12, okay? And once I get that answer, I'm going to divide that answer by the entire thing inside the bracket, which is going to be 1 minus, I'm going to open another bracket, 1 plus, the interest rate is 0.1, so that's 0.1 over 12, okay, and I've got yx there, that's minus 10 times 12, okay, and in this case I'm just going to close that bracket. Okay, so there we go. So which means if he's to she or he is to complete this in 10 years, they must pay actually an amount of 3,303 cents, right? And they said correct to 2 decimal places, so this is going to be and 77 cents. So that's 3,303 and 77 cents. All right, so the next portion says if you decide to pay 6,000 per month, only starting at the end of the second month, then how many payments will be made to pay off the loan? And we must round this to the nearest number of payments. Right, now I want you guys to see this. So remember, we were actually asked by the bank to pay 3,300 if we were to finish in 10 years. But if we decide to pay more in this case, definitely we are going to to finish much sooner. But now notice that first of all, right, we only start paying in the second month, right? So I want you to please note, so whenever we've got a payment, so this is when we took up the 250,000 loan, right? So in the first month, this is where we were supposed to start paying, and it would definitely be just a normal pattern, right? So remember, whenever you take a loan, there's usually this gap here, right, between when you take the loan and the payment, right? So that would be the normal pattern. But now we delay in this case by a month. So what happens to this 250,000, right? So remember, it will accumulate interest, right, during this first month when I actually have to pay for it. Okay, so I'm no longer going to be paying off 250,000, but I'm going to pay off 250,000 together with the interest, right? So let me find out what the interest is there, and that will be the amount that I will be paying, right? And then, so from this point on, then we start making our contributions, right? So we'll have T0 here, T1, T2, and T3 all the way until Tn when I actually complete paying for this, right? Okay, so let's do this. So we're going to say, right, we're going to use our present value formula. So PV, right? But now, remember that present value is 250,000, but we are now going to add interest to it. 1 plus I, right? It's just a month's interest that will be added in this case, so that will be that will be added actually, right? So in this case, we want to know how much we are going to pay is 6,000, right? And we want to know how many payments that will be, right? So in this case, we're going to say this is for the future value. So this will be 1 minus, 1 plus I minus n, divided by I, right? So 250,000 n's interest for a month. So that will be 0.1 over 12. We're still using the same conditions as before, so that's 10% that is compounded, so that's over 12, right? That's only in a single month that will accumulate interest. So in this case, that's 6,000. That's the value that I actually am paying on a monthly basis. So that's 1 plus 0.1 over 12, okay, and minus n divided by 0.1 over 12. All right, ladies and gents, I'm going to try by all means to do this from a calculator. Okay, so that's 250,000 into 1 plus 0.1 over the 12, okay, and right to the exponent 1, so I don't need to actually write anything there. Right, so I'm going to multiply by that number. So multiply all of that by 6,000. Not by 6,000, by 0.1 over 12. That's 0.1 over 12. And I'm going to divide all of that by 6,000. All right, so that's the value that we get there. Right, now the value that we have in this case, now I want you to see on the left hand side what we have there. We are now left with that entire bracket, right? So I'm going to take that 1, okay, because we've now cancelled that, we've divided by 6,000, so we are left with that. So I'm going to say minus 1, okay, so this is going to be all of that minus 1, okay, we get negative 0. Right? Now, all we are simply going to do, ladies and gents, is we are now going to put our logarithms, right? So we're going to take all of that and put them in logs, right? So that we get the value of minus n. So let's do that. So we're going to say that's minus, so that's going to be minus n, the log of 1 plus 0.1 over 12, right? And this will give us the log of that answer that we have over there. Right, let's do that quickly. So we've got a final answer. Okay. So I'm going to say the log of our answer. Okay, so the log of our answer, right, so that we don't, we do not, round off at this early stage, divided by, we're going to take the log of 1 plus 0.1, so that's 0.1 over 12, okay, and in this case, what does that give us? Right, so that would be negative 51, and so remember minus n is equal to that, so n would be 51.93. Right, so remember that would be the number of months, isn't it? So that means that in this case n, and they said we must round off to the nearest number of payments, so that would be around 52. So n would be equal to 52 payments. Okay, so that is the number of payments that we would make. All right, so I hope that makes sense, ladies and gents, as we're going to move into the next question. And now we start with section B of this question paper. Question 7 says, if x squared minus 16x plus 73 is equals to a into x minus m plus p, determine the values of m and p. So what that means, ladies and gents, is that we're just simply going to represent the left in this form, And what it needs us to do is just to complete the square of that. Okay, so we're going to say this is going to be x squared minus 16x. Now, if we complete the square, we're going to put the 73 just a little bit further. Okay, so we always say take the middle term, divide by 2 and square it. So that's going to be minus 16 over 2 squared. So negative 16 over 2, that's going to give us 8, right? So that's going to give us negative 8 squared, right? Now, negative 8 squared is 64, right? But what I'm going to do is I'm just going to represent this as plus. So we are adding a 64 there, or minus 8 squared. Okay, right. But now we've added something that wasn't there before, right? So we've added 64. So to balance this equation, we must subtract 64 as well from the entire equation. So we are adding it and subtracting it, right? And so what does this become? So remember what this is in the bracket now. It factorizes to become x minus 8 all squared. Okay, and so that's why I left that as minus 8, so that you'll see what it becomes, right? So that's x minus 8 squared plus, so we've got 73 minus the 64, right? So 73 minus the 64, okay, this is me being lazy. This is plus 9. Okay, so in this case, there we have it. So this is equal to a. So our a value is 1. That means our m value would be, that's plus p, right? So m is equal to 8 and p would be equal to 9. Okay, right, that is how we would do that. Okay, let's go to the next question. They say if 2 exponent x is equal to k, determine the following in terms of k. Right, so 2 of 2x, remember this is the same as 2 into x squared, right? So that simply is k squared. All right, and 2 into x over 3, right? So 2 raised to the exponent x over 3. So this simply becomes 2 into 2x raised to the exponent 1 over 3. So this will be k exponent 1 over 3, or you can say the cube root of k. Right, and the next one, we've got 2 minus x plus 1. So 2 minus x, remember, guys, if we've got minus x, okay, this is 2 minus x times 2 to the exponent 1, right? So remember, 2 minus x is the same as, in fact, let's write this as 2 over 2 exponent x. That's how it would look like, right? So in this case, this would be 2 over k. All right, so that is how we will write that. Okay, now the next question, they say solve for p. All right, if we've got that. Okay, one of my students asked me the other day, so here is the solution. So this will be 3 log of p to the 2 divided by, so I'm going to try and represent log 8 in this case as log p. Okay, I mean log 2 as well. So we're going to have 3 raised into the log of 2 exponent 3, right, base of p, and I can represent this as 3 squared as well, right, so that the bases are actually the same. Right, so now what I'm going to do here is, in fact, just to make this easier, okay, so let's say this is going to be 3 raised to the log of 2 base p divided by 3. Right, now remember when we do our jump down rule, this becomes 3 log base log of 2 the base of p. All right, so that is what it becomes. Now, if you just want to make things a little bit easier for yourself, right, why don't we just substitute that log p there? Let's say let log 2 base p equal to k. Right, I'm going to use k method substitution there. So this would be 3k, 3 raised to the exponent k, divided by 3k and 3k over there. Right, I'm sure that you can actually, it becomes so much better when we do it in that form. So this will be equal to 3 squared. Okay, so if we take that, so we're going to have 3 into k minus 3k. That gives us minus 2k, right? So if I take that to the top, that will be minus 2k. And this will be 3 squared, okay? And in that case, it means that my bases are the same. And I can now drop the exponents. So this is minus 2k, which is equal to, minus 2k is equal to 2. Okay, so k is equal to -1. All right, so remember we are looking for to solve for p. So that means in this case I'm going to take log p. So in this case I've got log of 2 base of p is equal to -1. So now remember, we said that p becomes the base, that becomes our exponent. So p minus 1 is equal to 2. All right, so that's 1 over p is equals to 2. So we can write it in that form. So 1 over p equal to 2. So therefore p is equal to 1 over 2. I invert both sides. So therefore p would be equal to 1 over 2. All right, ladies and gents, and that is really how the cookie crumbles, right? And I hope that it made sense. Right, so we move on to the next question. Question 8. Right, so we start with question 8, and they say in the diagram below, we've got f of x, which is 12 over x, right, for x greater than 0. They say G is the axis of symmetry of F, right? And they say B is the point where F intersects G. Okay, so which means that we are looking at that point over there, right? So they are intersecting over there. So they say H is the tangent to F at C. And finally, they say A is the y-intercept of H. All right. Now, let's quickly have a look at it. So we've got a hyperbola, but only the one part of it where x is greater than 0. They say write down the equation of G. Now, remember that for the hyperbola, we always have the axis of symmetry, right? Having a positive gradient, that's y is equals to x plus k1, right? Or y is equals to minus x plus k2, all right? So in this case, we know that it's going to be y equal to x because our y-intercept for the axis of symmetry is 0. So that simply will be the line y is equal to x. Right, so the next question, they say determine the coordinates of B. Leave the answer in third form. Right, now remember, in this case, what does B represent? The intersection, the point of intersection between those axes of symmetry, the line y is equals to x, and that the equation of f of x, which is 12 over x. Okay, so in this case, it means that this is where f of x will be equal to, we said it is g, right? So this is equal to g of x. Okay, so this is where 12 over x is equals to the line y is equals to x. And so we can do our gymnastics there. So that's over 1. So cross multiply, that gives us x squared is equal to 12. And so x will be equals to the square root, right, of plus or minus 12, right? They said we can leave the answer in set form. Remember that 12 is 4 times 3. So square root of 4 is 2. So we can actually simplify that. That's plus minus 2 root of 3. Okay. But in this case, remember, we're only going to take the positive value, right? So in that case, it means that x will be actually equal to only positive 2 root of 3. Okay, right. So, and they said the coordinates. So what would be the other coordinate? What would be the y coordinate of it? Right, so remember we've got the line y is equal to x, so which means whatever the value of x is, y would have the same value. So this would be 2 root 3 as well as 2 root of 3. All right, nothing wrong if you left it as square root 12, square root 12. There's absolutely nothing wrong with that. Okay, so in this case, they said determine the area of triangle ACO if h of x is minus a third of x plus c. Right, so let's go and see. Now remember they said that h of x is a tangent, right, to the graph of f. Okay, so they told us that they said h is a tangent to the graph of f at c. So to get a triangle, so triangle ACO, right? So we are looking for the area underneath that triangle, right? So first of all, if we can find out what the length of AO is, all right, so half base, and in this case, then it means our height, if I can just use a different color just to show it. So our perpendicular height will be this guy over there, right? So that will be perpendicular. So that will be the perpendicular height. So we definitely need to get the coordinates of C, right? So let's first find that out. So where is the gradient? Equal to a third, or minus 1 over 3. So I'm going to take the equation of f. Remember f of x, we said this is 12 over x, right? So now f prime x, okay, will be equals to, that's minus 12 over x squared. And we're saying this is equal to negative 1 over 3, right? So let's try and do our gymnastics there. So the negatives can cancel. So I've got x squared is equal to 12 times 3. That gives me 36. Right, and if I take the square root of 36, that's plus or minus 6. But remember, we're only going to take the positive value, right? Because we're in the first quadrant. So, which means that x will be equal to 6. Now, in this case, I'm going to look for the y value. Okay, so by substituting back into f, so f of 6 will be 12 divided by 6, and that gives us 2. So which means the coordinates of C are 6 and 2, right? So at least we know that much now. Okay, so we also need to find, now remember, we needed to find the coordinates of A, right? The y-intercept of H. So I'm going to take that line, h of x. So h of x, in fact, let me write it there so that I've got a little bit of space. So h of x. So remember, h of x gave us, all right, we've got minus 1 over 3 x plus c. So in this case, I'm going to just substitute the 0.6 and 2 there so that I find the c value. So I know that when x is 6, right, minus 1 over 3 of 6 plus c, then y is equal to 2. So what becomes our c value there? So we've got negative 1 over 3 times 6. That will give us negative 2. If I take that to the other side, c will be equal to 4. Okay, so the equation h of x is equal to negative 1 over 3 x plus 4. But what that simply means, if we go back to the graph, right, so which means the coordinates of a, right, that's y is equals to 4 there. The coordinates of c, this is 6 and 2. Now, if you think about it, our base, if I look at it as my base there, our base will be 4, right? And our perpendicular height will be the distance of the x value, right? So it will be 6 there. So the area of triangle, so area of triangle ACO will be equals to half base. We said our base is 4, and our perpendicular height in that case will be the x value at C, and that is 6. And in this case, ladies and gents, I'm sure you can see how that will be 12 units squared. Okay, right, so every time we look at area, we're going to square the units, right? And that essentially is how we conclude question 8. And off to question 9. We're on a roll, ladies and gents. So they say if in the Cartesian plane below, a piece of rope is hanging over the top of two vertical poles A and B, AB and CD. They say the poles remain vertical at all times and are 5 meters in height. The horizontal distance between B and D is 12 meters. Point E, which is 1 and 2, represents the lowest point of the rope. Now, all right, so firstly, I see that this rope kind of represents a parabola with a turning point, in this case at E, which is 1 and 2. Okay, and in this case, they've given us the y-axis as well as the x-axis at the bottom over there. Right, so they say if the shape of the rope between the points B and D is modeled, right, by the equation y is equals to x minus p squared plus q, so that's the equation of a parabola, they say then determine the values of a. Now I want you to please note, ladies and gents, so that means we already know what the values of p and q are. So that's going to be minus 1 squared plus our q value is going to be 2, right? Okay, so we need to find the value of a. So how are we going to do that? So remember that the x value of the x-intercepts rather, in this, or of the turning point rather, the x value of the turning point simply represents, in this case, halfway or midway, or that's what we call the axis of symmetry. So if the total distance is 12, it means it would be 6 units that way. It would be another 6 units going to the left as well. So that means, in this case, if my x value is 1, right, if I go 6 units to the right, where do I end up? I end up at 7, right? But remember they said that the vertical distance there is 5. Okay, if I go to the left, where do I end up? 1 minus 6, that will give me negative 5. But remember my vertical distance of the pole is also 5. All right, so I can actually just substitute any of those points to get the value of a. Let's take this one. where y is 5. Okay, we know our x value is 7. Okay, so that's 7 minus 1 squared plus 2. Okay, so in that case, I'm going to take the 2 to the other side. We get 5 minus 2, that will give us 3. Okay, that's a. Now 7 minus 1 gives us 6. And 6 squared is 36. Okay, right, so that gives us 36. And so if we divide by 36 on either side, right, so we've got 3 over 36. Okay, that would be our value for a. So a would be 3 into itself once. Okay, and into 36, that will be 12 times. So this would be 1 over 12. Okay, right, so that is what the value of a will be. Okay, so let's go on to the next question. They say if pole CD is shifted to the right. Okay, so which one is pole CD? Okay, so if we shift this pole to the right, okay, so in this case we've got, so they say then what should the horizontal distance between the two poles, vertical poles A, B, and CD become so that the value of A is 1 over 100 and the lowest point on the rope is 4 meters from the ground. Shoo, okay, so now they said our A value must be 1 over 100. They said the lowest value must be 4 meters, right? But now we've shifted the horizontal distance. So in that case, I'm not sure if our turning point will still be at the same point. So I'm just going to say x minus p, right, squared, plus, in this case, I also have q, but they said my q value is 4, right? In this case, they said the lowest value must be 4. So I know the y value of the turning point. Right, so let's do this. Let's find, in this case, what p should be, right? And which point can we substitute? I'm going to substitute, in this case, the value of that vertical pole, which is AB, because that's still fixed, right? So in that case, it still is 5, and it's still at negative 5 as well. So I'm going to say, right, I know that when y is 5, okay, 1 over 100, that's x minus p. Well, the x value rather is negative 5 as well, right? So that's negative 5, okay, plus p squared, right, plus 4. Right, so let's try and find out what the p value is. So that would be 5 minus the 4, that will give us 1. Okay, and we're going to multiply by the 100, so that gives us 100. You can solve this in any way that you like, ladies and gents. So this would be, right, so that's minus 5 minus p, right, squared. Okay, if I take the square root on both sides, so that means that I've got plus or minus 10, which is equal to minus 5 minus p. Okay, right, so our p value can be one of two. So minus p minus 5 equal to 10, or minus p minus 5 can be equal to negative 10. All right, so let's see which one becomes possible. So that's minus p is equal to, if I take that to the other side, that becomes 10 plus 5, that's going to be 15. So p can be negative 15, right? Or minus p, if I take that to the other side, that's minus 10 plus 5, which gives us minus 5, so p is equal to 5. It looks like this one is the more plausible one, right? So in this case, this is not applicable. So p can be equal to 5. Now think about it, ladies and gents. If my p value, so which means this is the x value of my x-intercept. Now note, in this case, it would now be at 5. All right, I am correct, right? So it now would be at 5, okay? And if it is at 5, then it means that, and the y value, so the other point is still fixed, right? So which means that p, right, my turning point would now be at 5, and what was the y value? I think at 4, right? We said at 5 and 4. So now I want you to note that this value still has not shifted, okay? So what would this one have shifted to? So in this case, I'm just going to take the difference between my x values, between the turning point and that other vertical pole, right? So this would be negative 5 meters. So that's 5 minus a minus 5. So this would be 10 units. All right. So which means it must also be 10 units going that way. So if it's 5, then it means that vertical pole must be now at 15, right? So please, I want you to note, so it must be at 15 because I'm going to add 10 to the 5. That's the turning point, right? So what was the question? The question was, okay, so what should the, if the pole is shifted to the right, yes, and it should be shifted to the right, so that the horizontal distance between the two vertical, so that the value of A and the lowest point is 4 above the ground. What should the horizontal distance between the two vertical poles be? All right, so the vertical distance now, you remember, that should be 20. So it would be 10 units and another 10 units. So the vertical distance should be 20. Okay, so vertical distance, all right, should be equal to 20 units. All right, so that is how we're going to do that question. All right, ladies and gents, we go to the next question. And now off to question 10. They say a pool is being filled by a hose pipe. The rate of flow increases by 10% each hour, and the table below illustrates this process. So there we are, we've got that rate of flow in each hour and so on. Okay, that's 1 liter per minute and so on. Right, now in this case they say to us, calculate the rate of flow during 24 hours. So first of all, acknowledge that in the first hour, our A value, right? So this is a geometric sequence, definitely. They say assume that the geometric pattern continues. So our A value is 1, right? And our R value would be 1.1 T2 divided by T1. So 1.1 divided by 1, so our R value will be 1.1, right? Now in this case, they said to us we need to find out the rate of flow in 24 hours. So that would mean that we're looking for T24. And remember, this is AR, right, n minus 1. Well, Tn is ARn minus 1. So if we're looking for T24, this would be 1 times 1.1. Sorry, I said R is 1. It should be 1.1. Okay, so 1.1, that's 24 minus 1, right? And let's quickly have a look at it. So this is going to be 1.1. 1.1. This is to the exponent 23. And that means that we would be at 8.94 in 24 hours. Okay, they say calculate the rate of flow, so that would be 8.94. Okay, so in this case we're given that we should leave the answer to one decimal, so I'm going to just simply say this is 8 point let's actually say 8.95, so this is going to be 9, right? Okay, so 8.95, yeah, let's just say this is going to be 9. Okay, so that would be 9 liters per minute. All right. Now, let's go to the next question. They say to us, if the hose pipe above is filling up a pool, right? How many liters of water would be in the pool at the end of 24 hours, right? So assume that the pool was empty at the start. So we're assuming that we are filling up a pool in this case. So that would be the sum, right, at which we are filling up this this pool, right? So in this case, every single hour we would be increasing by 1.1 liter per minute, and in that case we are looking for the amount in 24 hours. So what we are going to do, okay, so 1 hour it was 1 liter per minute, the second hour it's going to be 1.1 liter per minute, right? So in this case I'm going to take Sn, right, the sum of the terms. So remember, that's going to be A into 1 minus Rn divided by 1 minus R, okay? 1 minus R. So our A value, that's 1, okay? And that's 1 minus 1.1, okay, exponent n. And our n value is 24 hours. Okay, this is going to give us 1 minus 1.1. All right, so let's quickly find out there. Okay, so we've got 1 minus 1.1. In fact, let's do this. Let's say 1 minus 1.1 exponent 24. And this is divided by 1 minus 1.1. Okay, so we're saying this is going to be 88.5 liters. Okay, right, so in that case that gives us 88.5 liters in 24 hours. That would have been that would have filled the pool, right? Okay, so to the next one. And on to the next one. So they say if the hose pipe is filling up a pool, then how many liters of water would be in the pool at the end of 24 hours? Assume that the pool was empty at the start of the process. All right, so what I'm going to do, ladies and gents, remember that we are filling up the pool, right, at a rate of 1.1 liters, or rather 1 liter per minute, and it keeps increasing like that. But now I'm going to take the sum of that. Okay, so that means that to get the amount of liters in a pool in 24 hours, that would be sum of the liters that have been filling up, right? But I'm going to say, well, it's going to be A into Rn minus 1 divided by R minus 1, right? So the sum of the terms, that's going to be 1. That's going to be our R. We said that's 1.1, right? So this is S24. Okay, so this is S24. This would be in 24 hours, right? So minus 1. Okay, this is going to be divided by 1.1 minus 1. All right, so let's find that out. So this is 1.1 exponent 24, not 2. Exponent 24. So you see, I'm still squaring there. Okay, 24, right? And this would be minus 1. And this entire thing is divided by 1.1 minus 1. And we get 88 point, let's say 88.5, okay? So that gives us the sum of the terms is 88.5. But ladies and gents, I want you to be really careful here, because remember the rate was in minutes, right? Per minute. So this is 88.5 liters, okay, per minute. But in this case, if I wanted to find out in hours, how many hours are there? How many minutes are there in an hour? That's 60. So that means that if I wanted to find out the number of liters that would have been poured into the pool, I'd take that 88.5 and I'll multiply it by 60, since we are doing this within the hours, right? So that would be 88 liters per minute, right? We did that for 24 hours, but now we're going to take that value and we're going to multiply it by 60. Okay, so I get an amount of 5,300. Okay, let's say 5,310, right? Okay, so let's say that's the amount of liters that would be in the pool, right, in those many hours. Okay, right, let's go to the next question. So they say to us, for a quadratic sequence, the following information is given. Okay, they give us T2 minus T1. Okay, so they say T2 minus T1. So this is the first difference rather. So if we had T1, if we had T2 and T3, right, the first difference, T2 minus T1, that would be 4. And they say T3 minus T2, this is 7. Okay, and now they give us T10. Okay, right, now note in this case we've got our first difference. We can also find the second difference. Remember, that is a constant common difference. 7 minus 3 would give us, 7 minus 4 rather gives us 3. So that means that 2a will be equal to 3. We know 3a plus b would give us 4. And this guy would be a plus b plus c, but we don't know what that guy is, right? So in this case, what I'm simply going to do, ladies and gents, I am going to say, right, if they've given us T10 instead, we'll get to that in just a bit. So I know 2a will be equal to 3, so a will be 3 over 2, and 3a plus b will be equal to 4. So my b value will be 4 minus 3 times our a value is 3 over 2. Okay, so this will be 4 minus 9 over 2. Okay, and that's 4 minus 9 over 2. And I get a value of negative 0.5, right? Okay, so that would be minus 1 over 2. All right, now, ladies and gents, that's my b value. Right, so which means the sequence is almost done. So Tn would be a value is 3 over 2 n squared minus 1 over 2 n, right, plus, in this case, we want our c value, right? But what do we know? We know that T10 is equal to 0. So I'm going to substitute 10 there. So 3 over 2 times 10 squared minus 1 over 2 times 10 plus c, this would be equal to 0. And if I take that, okay, so that's 3 over 2 multiplied by 100. So let's do this. So we're going to say 3 over 2 multiplied by 10 squared, okay, and that's minus 1 over 2. This is multiplied by 10. Okay, so that gives us 145. and if we take it to the other side, it becomes negative 145. That's our C value, right? So we wanted the nth term of the quadratic sequence. That would be Tn. That's 3 over 2n squared minus 1 over 2n minus 145. All right, and let's go to the next question. They say the first term of a converging geometric series is equal to the common ratio, okay? And they say if the sum to infinity is 1 over 5, then the value of the first term in the series, calculate the value of the first term in the series. Now remember that A is equal to R in this case, so sum to infinity would be equal to A over 1 minus R. But we remember that A and R are exactly the same, so, and this is equal to 1 over 5, right? So we can say, well, if we cross multiply, we've got A, or 5A, right, equal to 1 minus R, but we know that R is equal to A, so I might as well just put that there, right, 1 minus A. And if I take that to the other side, the A becomes 6A is equal to 1, and A will be equal to 1 over 6, right, and that would be my first term of the sequence. Right, and in this case, we've got the geometric sequence that is given. We've got x, y, and x plus y, where x is greater than 0 and y greater than 0. They say determine the numerical value of x divided by y. Now, if you note this, so essentially, we know that it's a geometric sequence. So that means T2 divided by T1 will be equal to T3 over T2, right? So let's try and put that there. So T2, that is y, right? T1 is x, and in this case, T3 is x plus y divided by T2, which is y. Right, let's cross multiply and try to solve that. So we've got y squared is equal to, this is going to be x times x plus y. So that's going to be x squared plus xy. Right, so we were looking for the numerical value of x over y. All right, so how can we write it in such a way that we've got x over y? So we'll have y squared. In fact, let's write it as x squared minus plus xy, right, minus y squared. And this is equal to 0. Let's use the quadratic formula. So if we use the quadratic formula, then x, okay, the value of x, and that's minus b plus minus the square root of delta, which is b squared, minus 4ac. This is divided by 2a. Right, so in this case, what we have is our b value. Now note that our a will be 1, our b will be y, right, because x is our variable, and our c value will be negative y squared. Okay, so that's going to be minus b, which is minus y, plus minus the square root of b squared, this would be y squared, minus 4 times 1, okay, times c, which is negative y squared. Okay, this is divided by 2 times a, which is 1, right? So we've got minus y, plus minus, and the square root of. Now we've got y squared plus 4y squared. That will give us 5y squared. This is divided by 2. Okay, so I'm just trying to make some space there. Right, so in this case, remember that's the value of x. So x would be equal to minus y plus minus root 5 of y divided by 2. Okay, I can see how we're going to get x over y from that. So x equal to, so the first one would be minus y. So if we take out y rather as a common factor, so y would be equal to, so we'll be left with 1 plus or minus square root of 5 over 2. In fact, you know what? I'm just going to leave it in that format there. So divide both sides by y because we wanted to find the ratio there. So x over y will be actually that entire ratio. That's 1 plus minus root 5 divided by 2. That's the numerical value. And sorry that I had to squeeze that in there. I did not have enough space. All right, I hope that makes sense, ladies and gents. We'll go into the next question. And now we'll look at question 11. They say after some research, you decide that the best option of your online security is to have 2 unique passwords before opening important documents. They say the first 10 digits password consists of 2 parts, right? The first part is made of 6 digits. The numbers that can be used are the numbers from 1 to 9. How many unique 6-digit codes can be created if repetition is allowed? Now, ladies and gents, what I'm going to do is every time I do the fundamental counting principle, I always like to just draw my scenario, right? So I'm trying to make a 6-digit code, right? And I've got 9 digits that are given to me, which are 1 to 9. So these are all my spaces. So in this case, what I need to know is how many codes can I use, or how many digits can I use in my first block? Well, I've got 9 to choose from, right? But because repetition is allowed, in the second one, I can still use all 9 to choose from. The same is on the third one, the fourth one, the fifth one, and the sixth one. So in this case, which means that the number of unique codes that I can create will be 9 exponent 6, right? Raised to the power 6. So I'm going to say this is 9yx6, and that will be equal to 531,441. And that's the number of unique codes that I can create. Now they say to us, the second part is a 4-digit code compiled from the digits 1 to 9. Repetition is not allowed. Okay, so we cannot use the same number twice. How many even 10-digit codes can be created by combining these 2 parts? Now, I want you to note in this case, firstly, they said to us the code has to be even, okay? Right, and we are combining the 2. So let's start with the 4-digit code. So in my 4-digit code, please, I want you to note, ladies and gents, now for the 40-digit code, what I would do is, remember, repetition is not allowed. And they did say that it must be even numbered, right? So what I'm going to do is, all right, so there are my spaces. So for the even numbers, which ones are the even numbers between 1 to 9? That would be 2, 4, 6, and 8, right? So in that case, it means I will start there. I'll say, well, we've got 4 even numbers, but now I need to find out how many digits can I now use. So if I use the 4 digits, right, the 4 even numbers, how many numbers can I choose from? All right, so now I can choose from the other 8. So that would be 8. Of course, once I've used these 2, I can choose from the 7. Once I've used the 3, I can choose from the 6. All right, so now the number of codes that I can make from that, that would be 8 times 7 times 6 times 4, right? So, but remember that I need to also use the ones that I have there to make a to make a code that is made out of those two parts. So it will be, right? So that's 8 multiplied by 7 times 6 times 4, which gives us, okay, so that's 8 times 7 times 6 times 4, right? And this is multiplied by 531,444. Okay, so I get a number. So this is multiplied by 9 exponent 6. So the total number of combinations can be 714,260,736. So that would be the number of digits that I can create. All right, so we move on. They say to us the second non-digit password has to be a number that is greater than 600,000, right? With the last digit being divisible by 3, right? How many 9-digit passwords are possible if you can use the digits from 1 to 9 and no repetition is allowed? Now, ladies and gents, let's do that again, right? So in this case, that's 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? So we want to make a 9-digit password, right? A 9-digit code. So now they said it must be greater than 600,000. Now, ladies and gents, and also they said it must be divisible by 3. Now think about it. So that means that the first number must be a number that is 6 and greater, right? So now we've got the numbers 6, 7, 8, and 9. Now please, I want you to note how many numbers are divisible by 3 there, right? So numbers that are divisible by 3 are 6 and 9. Now the reason why I'm picking these numbers out is in this case, so in my first digit, I can use either 6 or 9 first, so which means I can't use either one of those numbers in my last digit because then those are divisible by 3. So I'm going to start with the first number divisible by 3. Okay, so divisible by 3, that would be 6 and 9. So how many do I have to choose from? I can choose from 2. Now, in this case, if the first number is divisible by 3, how many can I choose from in the last one? So remember, in this case, how many numbers are divisible by 3, right? Between 1 and 9. So that would be 3, that would be 6, and that would be 9. But remember, you would have used one of these, right? 6 or 9 in the first digit. So how many can you choose from? Once I've used one, I can choose from 2, right? In this case, so that means, remember, I would have used either 6 or 9. So now I've used 2 numbers. How many can I choose from? I can use 7, right, out of the 9. So, and in this case, the remaining 6, that would be 5, that would be 4, 3, 2, and 1. All right, so that's the first combination, right? But in the second combination, if I do not use numbers that are divisible by 3 in the first number as the first number, okay, so in this case, which numbers are not divisible by 3? That would be 7 or 8, right? So notice in this case, if I've got 7 or 8, so I've got 2 that I can choose from, right? Now, I want you to please note, in this case, for my numbers that are divisible by 3, right? I want you to note, so how many can I choose from? I've got 3, 6, or 9. So notice that now I can use all 3 of them, right? If I did not use them there, so I can use them in this space here. So that will be 3, right? And what about the rest? Now I've used 2 digits. How many can I now use? That would be 7, 6, the 5, the 4, the 3, the 2, and the 1. All right, I hope that you guys can see it. So this was divisible by 3, and this one not divisible by 3. That is for the first number, right? So not divisible, even my spelling is missing in action, right? So not divisible by 3, right? So in this case, it means that that's 7 or 8, and in this case, my last digit has to be divisible by 3, and I could choose from 3, 6, and 9. And now let's look at that. So that would be 7 factorial, okay? And I'd say 2 times 2. So for the first one, that would be 2 times 2 multiplied by 7 factorial plus, in this case, the next one, that would be 7 factorial again. So this is 2 times 3. So this would be 2 times 3 multiplied by 7 factorial. All right, now let's see how many repetitions, or rather how many combinations we can make out of that, right? So we said 2 multiplied by 2 times 7 factorial, okay, plus we've got 2 times 3 times 7 factorial. Okay, so that gives us, all right, so actually I made a mistake there. I said 2 plus 3. So that's 2 times 3 times 7 factorial. And so that gives me a number which is 50,400. Okay, so that's the number of combination 9-digit passwords that are possible, right? That have the last number divisible by 3, and in this case that are greater than 600,000. All right, I hope that makes sense, ladies and gents. Let's move on to the next one. So they say you have 2 regular 6-sided dice. One is green and the one is red. You throw both of the dice at the same time and record the values, right? So remember, in this case, okay, we've got numbers between 1 and 6. So there are 6 possible combinations on each. So which means the total number of combinations, right? If you remember, that would be 6 times 6, right? So in that case, that would be 36, okay? Right, so they say the value of the green, G is the value of the green dice, and the R is the value of the red, okay? They say once you have thrown the 2 dice, you place the values into an expression which is f of x, that's x plus g, x minus r. And remember that g and r are the values of the green and the red dice respectively, right? And they say then answer the questions that follow. They say what is the probability that the y-intercept of the graph of f will be less than negative 29. Now remember what happens at the y-intercept, right? So the y-intercept, this is where x is equal to 0. So that means f of 0 will be equal to 0 plus g and 0 minus r, right? And in this case, they said it must be less than negative 29. So we've got minus g, right, times r. So g times negative r will be minus gr, less than 29. And that means that the product, right, of the two of them, so remember, that's less than negative 29. And so that means g times r. Remember that when I multiply by the negative, the inequality changes sign. So that means g times r, the values that you get should be greater than 29. Now, I want us to really think about it, ladies and gents, right? If I threw, let's say, a value of, let's say, 5 and 4, right? So what does that give us? 5 times 4 gives us 20, right? So in this case, it should definitely be a value that is greater than both those combinations, right? Now, if I took, let's say, 5 times 5, all right, that gives us 25, and even that value is actually less than 29, okay? But if I say 5 times 6, okay, let's say this is the red and this is the green. So if I say 5 times 6, in this case, what do I get? I get 30, and that value is definitely greater than 29. Again, I can have the red becoming 6 and the green give me 5, okay? And again, I'd get a 30 out of that combination, right? Now I can have the red become 6 and the green 6, right? And definitely that would give me 36. It's greater than 29. And again, I can now have them swapped around, right? If the red gives me, if the red gives me 6 and the green 6, right? Now I can have the red, in fact, no, there's only one possibility there, okay? Because I was just trying to say if they swap around. I mean, 6 and 6 is 6 and 6. So we've got those 3 possibilities, right? So now, ladies and gents, this is 3 possibilities out of how many? Now you remember I said to you, if I've got dice that can give me 6 outcomes each, so the total number of outcomes would be 6 times 6, which is 36. So which means the probability of the y-intercept giving us a number less than 29, in this case, it's when the product of them gives me greater than 29, and that's 3 possible outcomes. So that's 3 outcomes out of. So the probability in that case would be 3 possibilities out of 36. And if you want to simplify that, 3 into itself once and into 36 12 times. So that would be 1 over 12. Okay, right. Nothing wrong if you left it as 3 over 36. That's the number of outcomes that you'd get. Now they say, what is the probability that the roots of f of x equals to 0 will be real, rational, and unequal? Now remember, what would be the roots of the equation, right? If I go back to what f of x actually represents, right? F of x is equal to x minus, that's x plus g, and x minus r, right? Now, even if r and g were to be equal, whatever the outcome might be, let's say r is equal to 1 and g is equal to 1, right? There is absolutely no way that we can get equal roots, because in this case, if g is 1, that would be x plus 1, that would be x minus 1. So those would be unequal roots, right? And so in that case, that means our roots will always be unequal, right? But rational. Now think about it, right? The numbers 1 to 6, all right? Those in this case are numbers, those are whole numbers, right? So in that case, roots will always be rational. We'll never get a decimal for that, okay? And will the roots be real? Absolutely, because in that case, numbers 1 to 6 definitely are there. So we will always get roots that are real, that are rational, and definitely equal. So in that case, they asked us, what is the probability? The probability would be equal to 1, okay? The chances of that happening would be all the time, okay? So that is our answer. Right, and so to the next one, they say if h of x is negative 1g plus x plus g all squared plus 4 minus r, they say then what is the probability that if you throw the 2 dice and place the values into h of x, then the roots of h of x equal to 0 will be non-real. Now, ladies and gents, what I'm going to do is I'm going to now write this h of x as a quadratic expression, just a normal standard quadratic expression. So this would be minus, this will be x squared plus this would be 2gx plus g squared, right? So if I expand that bracket there, this is plus 4 minus r. So if I expand it, this would be negative x squared minus 2gx, right, minus g squared plus 4 minus r. So that means our a value is negative 1, our b is negative 2g, and our c value is minus g squared plus 4 minus r. Okay, now let's go and substitute that into delta. Now remember, guys, that for roots to be non-real, our delta value has to be less than 0, right? So what is our delta? That's b squared minus 4ac less than 0. Okay, so that tells me that my b squared is negative 2g squared minus 4 times our a value is negative 1, right? And this is multiplied by minus our c value minus g squared plus 4 minus r. And all of this must be less than 0. So I'm going to try and simplify that. So this is going to be 4g squared, right? So negative times a negative will give me a positive. So I'm just going to remove those and just make that positive, right? So this is going to be 4 times negative g squared. That would be minus 4g squared, right? Plus 16, right? 4 times negative r would be negative 4r. Should be less than 0, right? And look at what happens there. That cancels out. So that means that that's negative 4r should be less than minus 16. And if we divide by negative 4, remember, if I divide by a negative, the inequality changes sign so that r is greater than 4. So in order for us to have non-real roots in that equation, it means the outcome of the red dice must actually be greater than 4, right? So in this case, when it is greater than 4, it is when we've got 5 and 6. So which means the outcome of the red dice must be either 5 or, in this case, it must be 6. So it means it must be those two possible outcomes, right, out of the 6 that you've got, right? So it can be 1, 2, 3, and 4, but it cannot be 5 and 6, right, if we are to have rational roots. So in this case, our probability for having roots to be non-real, so the probability of non-real roots, okay, will be, right, if we've got 5 and 6, that's 2 possible outcomes out of the 6. And so that will be, in this case, 1 over 3. Right, I hope that makes sense, guys. And essentially, this question, I really sat for a while with it, just trying to figure it out. And now we're going to go into question 12. Off to question 12 we start. So they say below is the front view of a rectangular storage facility built onto a wall represented by MO. Okay, there is our wall there, which is MO, right? And okay, I'm just trying to indicate it with our pen. Right, so MO in the diagram, right? They say the roof is attached on the wall at M with MO being 6 meters. So they are telling us that this MO is 6 meters, okay? And they tell us that the gradient of the roof MN to NP, so MN to NP, which is this guy here, is 2:5, right? So if that was, okay, so this would be 2x. In fact, let's find another variable. I'm just gonna say this is 2a over 5a. right? So that's the ratio there. And they say PR is a vertical beam, right? Okay, and NP is a horizontal beam, right? And OR represents the ground. Now they say to us, determine the equation of the line MP, okay, that represents the roof. Okay, so now, first of all, I see that the gradient, remember, it's change in y over change in x, right? So our gradient, if you took change in y over change in x, you would actually get that ratio there, which is going to be 2a over 5a, right? Which will be 2 over 5. So our gradient of that line is 2 over 5, okay? And in this case, it crosses, right, at y is equal to 6. That would be your y-intercept, right? So the equation, quite simply, would be y, okay, or let's rather say MP. So the equation of MP would be, okay, which is, yeah, they did call it y, so we might as well just call it y. So the equation is y is equal to 2 over 5 x, right? So this is x going that way, right? Plus 6, which is the y-intercept. All right, that is the equation. Okay, so the next portion, they say below is the rectangular storage facility under the roof MP shown in three-dimensional form. Okay, so they say if the depth of the rectangular storage facility is 2 meters shorter than the width. Okay, so what I'm going to do, ladies and gents, let me call the width x, right? So if our width is equal to x, then it means that the depth of this facility would be x minus 2. They said it is 2 meters shorter, right? So that would be x minus 2. And now they say then determine the length of the vertical beam, right? So the vertical beam, we want to know what the height is. Okay, so the height h in that case, let's call that h, right? So we want to know the height of the vertical beam so that the rectangular storage facility will have a maximum volume when placed under the roof. Okay, right. Now, please, I want you to note, guys, if we called this point x, right? So think about it. We said the width is x. Now, what would be the height here? That would be, remember that when x is that point, then it means here we've got 2 over 5 x plus 6. That would be the corresponding y value. And so in that case, it means that it would be the height of the vertical beam. So the height would actually be 2 over 5x plus 6. I hope you get that, ladies and gents. Now, what are we trying to maximize? We're trying to maximize the volume, right? They say to us, so that we have maximum volume. So in this case, we're going to say V of x, right? This is going to be the width multiplied by the depth multiplied by the height. So we're going to say width times the depth, okay, and this is multiplied by the height. Okay, so we know our width in this case, we said that was x multiplied by our depth was x minus 2, and we said our height is 2 over 5x plus 6, right? So we can actually find multiply throughout there. Okay, so I'm going to take x into, right, if we multiply throughout there, so x times 2 over 5x, that will give me 2 over 5x squared, right? This is going to be 6x, right? 2 multiplied by 2 over 5. So this will be plus 6x minus 4 over 5x, and this is minus 12. Okay, right, 2 times 6 will give us 12. And in this case, if I add those two, 6 minus 4 over 5, so that's 6 minus 4 over 5, and that will give me, okay, so I just want to be, I just made a mistake there. 4 divided by 5, this is 5.2. I'll just leave it as 5.2 just for the sake of it. Okay, so that will be 5.2. So these two give me 5.2x, right, minus 12. And remember, I multiply the 1 in there, okay, the x into that. So that's 2 over 5x squared, right? This is plus 5.2, this is x cubed rather, plus 5.2. If I write that as a decimal, okay, I'll just leave it as a decimal there. So this is 5.2x squared, okay, and this is minus 12x, right? And remember, we want to maximize, and every time we want to maximize, we make the derivative, we take the derivative and make it equal to 0, right? So I'm going to multiply that by 3. So that's 3 times 2 over 5. That will be 6 over 5 x squared, okay? Right, so 2 times 3 will give me 6 over 5, right? This is going to be 2 times 5, 2 times 5.2, which will give me 10.4x, right, minus 12, and this will be equal to 0. All right, ladies and gents, if I represent the 6 over 5, 1 over 5 is 0.2, right, so 6 divided by 5, that gives me 1.2. So I'm just going to write it in its decimal form. So that's 1.2 there. Right. And now let's plug this into our quadratic formula. So we're going to say, well, in this case, x is going to be equal to minus b plus minus. Okay, so remember that, we use our quadratic formula when we cannot factorize. And I'm not going to bother trying to factorize this. Right, so this is divided by 2a. Right, so now let's plug and play with the values. So this is minus, that's 10.4, right? That's our b value. That's plus minus the square root of, that's 10.4 squared minus 4 times a is 1.2. And our c value is negative 12. Okay, this is divided by 2 times the value of a. Right, our a value is 1.2. Right, so I've got two values. So let me try and get those values. So I've got negative 10.4. In fact, let's do this so that it will be easier for us. Okay, so let's say negative 10.4, right, plus the square root of 10.4 squared, right, this is squared, right, so I'm just simply going to say plus 4 times 1.2 times 12, right, because we had those negatives there, and this is divided by 2 times 1.2. Okay, that's 2 times 1.2. Okay, so I get a value of x being equal to 1.03. Okay, or I get, let's get the other value for x. I think it will be negative, right? So minus, it's definitely going to be a negative value. X is minus 9.6. Okay, 9.7 actually. right? But remember, because we're dealing with dimensions, we cannot get a negative value. So in that case, it means that I am going to take that value for x, which is 1.03, right? But now, please keep in mind, we were looking for the height of the roof, right? That was the question, right? So they said to us in the question, I'm trying to find the place there. They said to us, if the depth of the rectangular storage facility is 2 meters, then determine the length of the vertical beam. That's the part that I want. Okay, so now what must we do? We must put that value back into our equation, right? So that means we said our height of the vertical beam was 2/5, right? X plus 6. So in that case, it will be 2/5 multiplied by 1.03, right? And this is plus 6. And I am going to take that value, right? So I'm just going to have that value back. That's plus there. Okay, so we get that value. I'm going to multiply it by 2/5. Okay, and that will be plus 6. Okay, so I get a value of 6.4, right? So x is equal to, or rather the height will be 6.4 meters. All right, so there it is, ladies and gents. That will be the height that will maximize the value of, in this case, the the area, or not rather the area, the volume of the roof. Okay, right. I hope that you guys were able to have this make sense. And please, guys, please don't forget, if you want to get in touch with us, right, our email address is info@mlungisinkosi.co.za, but you can also get in touch with us, all right? We've got a WhatsApp number, all right, and that's the Mlungisi Nkosi Maths and Science Center, and our WhatsApp number is 064, right? So I'm going to write it down, 064, that's 554, and that's 7199. And for any of you who wants assistance with maths and science, you can get in touch with us. Our email address is info@mlungisinkosi.co.za, and in this case, you will be able to get all the assistance that you need. Otherwise, from me, your favorite uncle, I will see you guys again next time. Ciao for now.